Good morning, everyone. Thank you for joining Megger webinar. I'm Grace. I'm the marketing manager for Megger East Asia, and I will be the moderator today. Today is a live webinar. You automatically muted to prevent any background noises. During the webinar, if you have any questions, please type into the question box, which you can see on the left of your screen. We will answer your questions in the Q&A session. At the end of the webinar, please have a fill in the survey, which you can see on the right-hand side. We presented the presentation materials to those completed the survey. You'll be able to download an attendance certificate after you finish the webinar and completed the survey. And the recording of this webinar will be sent to you in 2 days' time after the webinar. Today, our topic is assessments of large rotating machine using online partial discharge detection, presented by Zumaedi, who is our East Asia application engineer from Megger, Indonesia. Zumaedi has over 19 years of experience in electrical engineering and has been 11 years at Megger already. He obtained a bachelor's degree in electrical engineering from the College of Engineering Technology PLN in Indonesia. His area of reflection is circuit breaker testing, and with more than 15 years of field experience in testing and commissioning. He's now playing a key role in the circuit breaker group at Megger and contributing a lot to the product innovation and development. So I'll pass the time to you now. Thank you for joining us today. Zumaedi, are you ready?
Yes, thank you very much, Grace, for your introduction. Yeah, welcome back anyone. Good morning, anyone. Hopefully you are in good condition. Thank you for joining again on the regular Megger webinar. So for today's topic, as Grace mentioned, I will talk about the partial discharge, online partial discharge measurement using as assessment for rotating machine, especially large rotating machine. So on today's webinar, the following are some topics that I will try to talk. I will talk about the introduction of the partial discharge, especially on rotating machines. Also, rotating machine insulation system. We also talk about the deterioration and condition assessment of starter winding. Some normative reference I also will show you as your reference when you do testing and analyze. And why PD monitoring on rotating machine, type of PD in rotating machine, some principal appearance of the PRPD pattern, and I will also share some typical rotating machine PRPD pattern. At the end, I will explain about the technical detail of the partial discharge measurement monitoring system as the main instrument to be used for this assessment. At the end, I will summarize all information that I talked on today's webinar. Okay, let's move to the first topic, introduction of the partial discharge on the rotating machine. Okay, if you see here, the partial discharge is a local insulation breakdown in small portion of an overall insulation system under the influence of an electrical field. So the subsequent electron affluence caused by require the accelerated free electron in this electrical field that result destructive high high frequency current impulse causing amongst other and also local heat. And only a fraction of this internal discharge impulse can be decoupled at the starter winding terminal. So this is, we normally call it as apparent charge as the sensor to be used for measure the partial discharge on the rotating machine. Even with today's optimized starter bar and winding processing techniques, a minus cool of the small gas inclusion or micro voids at the end cannot be entirely avoided. So common insulation materials that used on rotating machine have the important property to be partial discharge resistant, actually. Hence, that means the starter winding insulation can widely tolerate normal PD activity throughout their life cycle. Since partial discharge or PD are inherent to rotating machine insulation system, they serve as indicator for us, indicator of insulation deterioration, and one of the root causes of the starter winding failure over the time. So the performance of the starter winding in terms of dielectric losses partial discharge activity can be directly related to the quality of the insulation material that you use, the design of the insulation system, and controlling of applied processing technique, example like a VPI cycle. And the other hand, the operation mode, and it is associated to the, the TEM stresses play as a major role on partial discharge behavior under motor operational in normal condition. So the severity gradient strongly depend on the PD location or discharge site within the starter winding. The sample depend on the location where it is in the slot section, at the overhang, or at the field grading. Yeah. At the end, the condition assessment of starter winding is not matter of detecting partial discharge because they are already inherent, but accurate monitoring of the development of the initial reference data while focusing on the speed of deterioration and the development of the additional discharge site. Like a loss factor, or we call it as the time delta measurement, and also offline partial discharge measurement are perfectly good testing to unveil winding deterioration in both factory tests and also in the site tests with the field environment. The major advantage of high frequency measurement technique, such as the PD measurement, is possibility to detect winding defect and fault mechanism, both in early stage, whereas maybe with the loss factor or time delta test, sometimes we late to detect it. So early detection allow us to intervening partial repair in early stage and often avoid the immediate rewinding. This is the last goal that we hope with our assessment actually. So if you see this slide, maybe some of you already familiar with this picture. Yeah, this is actually the past resolve partial discharge, or we call it as a PRPD pattern. Just give you brief information what is actually the past resolve partial discharge. So right now, this graph very common is used to analyze the condition or the type of the partial discharge, especially on the rotating machine. So I just want to give you brief information. If you see this, you can see here there are three axes actually: X axis, Y axis, and Z axis. So the X axis actually it is to illustrate the sinus wave from the voltage that you apply on the rotating machine or any asset. This is the implemented of the sinus wave depending on your frequency system, 50 hertz or maybe 60 hertz. So if you have 50 hertz, the sinus wave length is around 20 milliseconds up to this point. So x-axis is the sinus wave, and the y-axis, if you see here, it is the amplitude of the partial discharge measurement. Either you measure with the picocoulomb value, millivolt, or dBm. So the y-axis showing you the magnitude of the PD. And for the z-axis, if you see, it is the number of PD pulse. So if there is a discharge impulse, the maximum discharge impulse will consider as the PD pulse. So in which area depend on the pace sinus. So an example, if there is a discharge pulse in this point, and only time maybe they can show you with the gray color. If happen at the same point many times, depending how many times, depending on the intensity, they will differentiate with the color information. So you can see here the table information relation between the number of discharge pulse at the same point with the log and log uh, algorithmic paper. So here at the end you can see the special behavior of special special pattern that very specific to inform you what is the partial discharge or type on your measurement. So it is the actually the past resolved partial discharge. So meaning you need to know the sinus wave of your voltage system, and then you can get the accurate PRPD analysis later on. Okay, now we move to the other topic, rotating machine insulation system. So when induction or generation under high voltage perform require a starter winding insulation system with sufficient electric strength, preventing insulation short under severe thermal, mechanical, electrical, and ambient stress. The main properties and function of the starter insulation system, if you see, here's some purpose. It can be used to introducing an insulated barrier. So the insulating starter insulation as the insulated barrier, and also to ensuring the optimal thermal conduction, to securing the copper conductor, and also being partial discharge resistant for the intended life cycle, and to make the thermal and mechanical stability. And again, the last purpose is protection against moisture and contamination insertion. So here, the illustration of the starter bar design in general. From this information, you can imagine uh, the starter bar design, because our concern on partial discharge will be on the starter bar analysis. So we need to understand the design of the starter bar to make easy analyze when you got the PD measurement. So this one is the conductor insulation or copper strand. This is actually multiple copper, not only single actually, but just pictures just showing one. And after that, you can see also the this one, sorry, the color is like the chocolate. Yeah, I mean, this is the strand insulation, and after this layer to the insulation, turn-to-turn insulation, and this area is ground wall insulation, can be made by mica tape layer or epoxy resin impregnated, and continue to the slot stress grading layer, or this one, and then this one after that the semi-con field grading, and also the end winding sealing. So multiple process to fill the conductor to the end winding sealing. Okay, next is the duration and condition assessment of the starter winding. This is the next topic that I will try to inform you. Yeah, in surface condition, starter winding are subjective to several stresses, often causing combined impact on the speed of deterioration of your insulation material. In the jargon of the rotating machine business, the type of stresses influencing the condition and aging of the starter winding, and are often referred as the TM or TIM stresses. TM stresses meaning T for thermal, E electrical, and ambient and mechanical. So the example of thermal is stress on the winding could be overloading with the consequent overheating. Electrical example is could be uncontrolled electrical surface field causing an elevated electrical stress. Ambient condition, we are talking generally about the humidity, temperature, and also contamination. And finally, the mechanical example, like a vibration as a structural overhang resonance, is common example of the mechanical stress. Yeah, high impact on the duration by the performance of manufacturing process, for example, is inadequate impregnation or FPI. So it is sometimes uh, the poor design in the manufacturing process. It can make you poor addition of the strand and turn insulation to the main wall insulation, maybe non-secure conductor stack, maybe loose starter bar with the slot, and also numerous remaining void and reckless causing the internal PD. Another example is improper design and or poor workmanship. It also may cause a fast increasing deterioration rate, like insufficient overhang spacing, maybe miscalculation of the overlap and semi-conductive layer length, bad combination of the impregnation agent and main insulation material, and also maybe inadequate wedge pressure. Yeah, manufacturing inefficiencies for design and processing shall accelerate the aging process and enhance the impact of the common operational team stresses. Consequently, is unexpected PD behavior may develop fast and so deviation from baseline measurement in comparable short time. In case of global gradual aging, we can consider to be normal. The assumed life cycle of starter bar actually up to 20 years. However, because PD fault mechanism developing on a critical position within the winding may cause the separate encouplement only. So the PD measurement are an excellent, I think, excellent diagnostic tools to monitor the starter winding condition and fit perfectly in the philosophy of the condition-based maintenance or CBM program. Yeah, this is some information regarding to the IPRI and IEEE studies. You can see here from these two document studies from many machines, they mention that 37% of failure come from the starter winding. So this is why I talk about the starter winding, because most of the cause failure on the starter from the starter winding. You can see both from 7,500 machine and also 3,000 machine from different publication studies showing the same rating. Meaning, I mean, starter winding quite influence on the cause of the failure, even though this is bearing. Sorry, number one, 50% is bearing vibration from the IPRI, and here also bearing related 41%. But at least if you can do assessment to minimize on the starter winding, at least you can minimize your failure for around 37%, maybe more. Yeah, if you see more detail, another studies the test on high voltage motor in petrochemical industry. You can see for high voltage motor below 2 megawatt and higher than 2 megawatt. You can see here that the starter winding also give a good percentage. You mean high percentage. You can see here from the higher than 2 megawatt, around 60%. This is number one cause of failure, but less than 2 megawatt, it is number two after a bearing failure, because for motor below 2 megawatts, bearing design is not really reliable compared to the motor higher than 2 megawatt, because they met with the roller barrel type. Yeah. Yeah, this is the failure root cause investigation, the importance of electrical and electric measurement, and this is some global recommendation for starter winding condition assessment. So there are some recommendation, like the first factory FAT test. The first time after manufacturer make the rotating machine, they will do FAT test, including with the offline PD and time delta measurement as baseline reference. So at least to this testing must be done as the isolation analysis baseline reference. And first offline inspection is after 6 or 12 months after the commissioning. You can do again the same testing, offline PD and also time delta. And also maybe further offline measurement every 2 years, and then you can compare result as trending data from previous result and recent result. Or alternatively, you can install a permanent installation of the coping capacitor for 6 monthly online PD measurement combined with full offline inspection every 4 or 5 years. So if you have this alternative, at least you can reduce the downtime of your machine with the regular 6 month online, because you don't need to shut down your system, but you still can get the information. And to verify it, you can do every 4 or 5 years. Okay, and this is some testing. Usually we do on the rotating machine. The visual inspection of the overhang and slot exit is very important, because you can see the visual of failure. Winding resistance and inductance measurement as the low voltage testing. With this information, you also can analyze the problem on the insulation and also connection issue. Source test, if possible. Some people, they prefer do this source test, because one testing can be used to analyze your turn-to-turn issue. And also insulation resistance with measure PI measurement also can give you the information of the insulation deterioration, insulation condition. This is step voltage test, like HiPod, but you measure the leakage current step by step. Or you can do long duration polarization or depuration test, time delta test with tip up procedure and capacitance test, offline partial adjust test, AC high potential test only after on-site repair size after rewinding. So most of this all testing, actually the main purpose is just to measure, to make sure the problem on the insulation material, especially on the stator or your rotating machine. So we try to do some testing with the same goal. So this is commonly done on the many surfaces on the rotating machine. And this is some normative reference. You can use this information as your reference. Yeah, there are currently no standard defining acceptance criteria for partial discharge on rotating machine. To be honest, yeah. The lack of the such criteria often cause endless discussion between the owner and manufacturer, or maybe the service engineer on the test to make the test report, even during factory test. So someone argue this value, another one argued another value. So this is because there is no standard defining acceptance criteria. An important difference between rotating machine and other applications is property to be PD resistant versus other PD-free insulation system. Yeah, as we know, the rotating machine actually is designed with the certain PD value. Well, even though, I mean, in normal condition, there is already PD on the rotating machine. So this is why difficult to find the acceptance criteria on the rotating machine compared to the other asset like transformer or maybe a switchgear and other. So this is why we have the frequently asked question on this subject: how much PD is now too much PD? Defining acceptance criteria for PD resistant insulation system. So until now still in the discussion. So mostly we just use experience information and manufacturer recommendation. Yeah, but actually there is a horizontal standard from IC 6270. So if you want to know more detail about the partial discharge testing, this is the one standard that very useful for us engineer or technician to learn about the partial discharge. So on this standard, there are some information like the test circuit, calibration circuit, how to do testing, or what type of PD on rotating machine, and on general application. And like the other standard like technical specification and guide from IC, triple E, SIGRI, EAC, SA, and EPRI also can give you information about the test circuit procedure, voltage, application sequences, test duration, bandwidth to detect PD, calibration circuit, how the circuit to do calibration, and also the important thing is typical PD phenomena. And other standard IEEE IC 6034-27, also good reference for rotating machine, especially for rotating machine. IEEE 1434 2014, SIGRI 258 and 558. So there are many standards actually, but commonly we can use some of them. But for me, depend on the application, especially if you concern on the rotating machine, you can focus on the IC 634-27-1 for offline testing. And for online testing, partial discharge measurement, you can refer to DAS2. And another good application, technical brochure from SIGRE, number 258, also good reference application of online partial discharge test to rotating machine. So three of these quite very good to be used for reference. Okay, why PD monitoring? So now we'll focus on the partial discharge as I explained before. Some reason why PD just focus on starter bar. Some reason I already explained before, and actually there are many testing, but you can see from this slide. Yeah, why PD monitoring? Because actually there are offline testing and online testing with some advantage and disadvantage, of course. So with the offline measurement, when we talk about the offline measurement, actually we refer to the IC62. We refer to the standard IC6270. So where is the starter winding is isolated from the power system, and separate power supply is employed to energize the winding. So meaning you need to external voltage source to do offline testing. Most important for laboratory and workshop setup, device under test has to be taken out of service. Noise source other than possible noise can be eliminated. So the good thing of the offline measurement, you can manage to reduce noise as maximum as possible. So this is why if you concern on the accurate measurement of the PD measurement, offline measurement is preferable, because this offline method can give you more precise about more accurate about the value of the partial discharge on your asset. Yeah, but the problem, you need to de-energize your system, your asset. And another option is online measurement. So on this method, the rotating machine is operating normally and connected to the power system. Typically for commissioning and testing on site, because the problem on site, we cannot manage the noise source minimum as possible, because depend on location, depending on environment, the noise is sometimes difficult to reduce it. Yeah. Allows for more frequent testing or monitoring, because online you don't need to shut down your system. You can do measurement anytime. The analysis measures strength in trending ability, and also permit examination of device condition throughout all factory of influence, like temperature, power loading, humidity, will be including on our the effect of this like temperature, power loading, and humidity will including with our measurement, meaning more real measurement to detect the early stage of the insulation failure. Yeah, the advantage of the online is the voltage distribution across the winding is the same as during operation, meaning you use the same voltage as normal operation. Okay. The measurements are made at the operating temperature. As we know, the temperature sometimes also can affect to develop partial discharge on the starter. So because if there is high temperature, as you know, the insulation has a relationship with the temperature. High temperature, insulation will reduce. If if I'm not wrong, 10 degree can make the half insulation capability reduce. Okay, so temperature only can be test. I mean, the effect of temperature only can be detected by online test, because you cannot do offline testing with the temperature with the temperature effect. Okay, and normal mechanical force are present. So because this is the online, so you will get the normal mechanical force. Sometime with offline, uh, cannot be simulated. So this is the some advantage online PD testing compared to the offline. So in general, the online PD monitoring to assess insulation health of the like hydro generator, turbo generator, motor, or other rotating machine. So PD trending and changing PD pattern indicate insufficient failure. So you can detect early. PD pattern analysis assist with the failure investigation. You can see the root cause analysis, and added failure if PD monitoring combined with the load, temperature, and other failure information, because some this all information affected to the PD behavior. Okay, this is the some type of PD in rotating machine. There are some type like internal discharge, internal void, internal delimitation, delimitation between conductor and insulation, electrical traying. Other type is discharge, discharge in winding, surface discharge, face-to-face discharge, and conductive particles. So I will try to show you some example and explain this. Yeah, this is the internal discharge. If you see the starter winding like this, external discharge, or we call it the internal void. Yeah, although manufacturing process are designed to minimize the internal void, but in fact there is some void content still exists. For example, in a resin impregnated mica tape insulation system that is commonly used in high voltage rotating machine, the mica in insulation system prevent the PD from developing into a complete breakdown. So as long as internal void are small and do not significantly enlarge, so operational is not reliability of the operational is not reached. So this is example some void depend on the conditions, sometimes small, sometimes getting big. And this is the internal delimitation. Internal delimitation within the main insulation can be caused by imperfect curing of the insulation system during manufacturing process, or maybe by mechanical or thermal over stressing during operation. So this is the same like the internal void, but here large void may develop over the large surface, resulting in discharge of relatively high energy. So it's almost the same, but this is the void with high void. And other example is slot discharge. If you see here, the cause of slot discharge because loose winding and wedges, and or maybe also a magnetic force between bars and between rotor and stator. So the process, this PD, like bars move relative to core, maybe not proper install, and then you can see abrasion of semicon coating, and a PD occur in the slot, can produce ozone as a result of this chemical gas. This is an example of turbo generator failure due to loose winding in the slot. And this is for surface discharge. The cause of this discharge may be because improper manufacturing, over high electric stress, over high temperature also can develop this surface discharge. The process starts from grading losses between ground contact and then float to high voltage, interface to ground spark, and also can produce ozone with wideband at slot exit. And this one for pass-to-pass discharge, you can see between pass-to-pass coil, you can see visually, you can see something like produce ozone. This is the PD pass-to-pass, and arrow and puncture the insulation. So still, you need to check visually to see this PD type. And this one, conductive particle, especially small particle, for example, due to contamination of the winding, may result in strong local concentration of the partial discharge. This may result in a pinhole in the insulation. So this is the example of the conductive particle. And okay, there are some partial discharge example. So now this is the principal appearance of the PRPD pattern. So many questions from some people, how to interpret, how to analyze when you got the partial discharge measurement. So actually, from some standard that I mentioned before, there is some guide to define what type of the PD, like surface PD or PD between phase, or other example that I mentioned before. So this is the sinus power frequency, and you can see the pattern position in which phase. They have the path 0, 90, 100 degree, 270 degree, and 360 degrees. So the location and shape of the pattern can give you information about the what type of the PRPD. So if you see this one, this is the negative half cycle, positive PD, like this. This negative PD. Now, this is maybe the detailed explanation. So for this slide, if you see, this is the power frequency wave, and this is the example of surface PD in slot. If you see here, the pattern should be around 0 and 90 degree, and the second one 180 to the 270 degree. But the predominate in magnitude here, mainly occurring during the negative half cycle. This one, negative half cycle, and this can be damaged conductive slot coating, and usually more pronounced during online measurement at higher load. So higher load can give effect to this PD type. So this is why sometimes you cannot detect when you do offline testing for this type of PD. And the other one is like this. So when the PD pulse, which mainly occur during the positive half cycle of the voltage waveform and predominate in negative in magnitude, sorry, the half positive, the first half positive half cycle more dominant if you see the magnitude compared to the negative half cycle. Okay, or for this case, the PD adjacent to the conductor. So the source of the PD can be expected to be at or near to the chopper strand and may indicate an incomplete bond between the insulation and the copper conductor. In the case multi-coil, there may be an inadequate bond between the turn. So the location, which one is higher magnitude, if in the positive half cycle is higher compared to the negative, meaning the source of PD close to the conductor. But if the higher in the negative half cycle, so meaning the PD source close to the ground insulation wall of the protecting machine. It is in general, but and then you also need to define the shape, whether triangle or circle also can indicate some PD type like this. This is PD pulse in positive half cycle, same with the negative half cycle. It can be internal delamination or PD between phases or metallic object in winding. Same range of magnitude. The magnitude in both half cycle same. Yeah, this can be expected to be surface discharge at the end winding or internal discharge. Void or delamination of the main insulation can cause this PD type. And this is the PD between two phases. How to define it? So you need to see the two pair PD from two different pairs. PD detected in one phase will be shift right, closer to the zero crossing of the AC cycle, and PD detected in the other phase, other measurement, other phase will be shifted left, closer to the peak of the AC cycle. So you just can detect this only during online measurement with cross-coupling effect. Whereas when you do offline, maybe you cannot detect this PD. Yeah, this is the typical rotating machine PD pattern based on the IC 634-27-2. So you can read this standard to get this information more clear, more detailed. This is example of the internal discharge or internal void. You can see the shape is rounded, like circle, rounded, and also the phase position in the positive half cycle is around 0 to 90 degree, and the negative half cycle 180 degree to the 270 degree. So if you see the typical pair PD like this, probably you there is internal void on your starter bar. It can be multiple layer depending how many void inside. If there are many void, many in insulation, maybe you can see multi-layer, but with the same characteristic like this, meaning the half cycle and the second cycle has the same magnitude. And if you see like this, like internal discharge, like void, but the PD pattern will be symmetric in the amplitude and PD cone, similar to internal void, but PD cone much higher than normal void. So just to verify with the cone of the PD cone, and also less rounded shape than internal void, because if you see in void, internal void more rounded compared to this type, less rounded shape, and sometimes almost triangular shape. So if you see already like three angular shape, it can be maybe delamination, internal delamination, or maybe other type of PD. This one, delamination between conductor and insulation. As I mentioned before, if the magnitude higher on the positive half cycle compared to negative half cycle. So meaning the problem of PD so close to the conductor. Negative PD will higher than positive. Negative PD occur between this angle and positive PD on this angle. And this is slot partial discharge. It's very specific pattern like this. So PRPD pattern is asymmetric. Positive PD will higher than negative PD because this is higher than negative PD, and triangular shape close to the triangular shape. This is the location of the pace 0 to 90 and 180 to the 270. Actually, this is a little bit moved because the cross scope should be around here because this on the another pace. The pattern looks like 180 degree. And corona mostly like this, same like void, but more higher on the negative. The positive PD will be higher. Sorry, positive PD will be higher than negative PD. And this one for surface tracking, you can see something like the vertical cloth of PD. So probably if you see the pattern like this, meaning the tracking discharge. It can be on positive cycle or negative cycle, but as long as you can see the vertical cloth, probably it is the surface tracking discharge. And opposite, if you see the gap type discharge, mostly you can see horizontal cloth of PD like this, horizontal in many area. So I know it's not easy, but with you have more experience, you can recognize exactly what is the PRPD type and what caused the insulation failure on your starter. And this one, technical of the some instrument. Yeah. So when we do measurement on the online partial discharge, we always refer to the frequency range measurement. So as we know, the rise time of the PD is around 1 nanosecond. We got this value based on the laboratory testing. So rise time of the PD on the nitrogen, where is the almost 80% nitrogen is air. So it's around 1 nanosecond. So this 1 nanosecond, if compared to the frequency range, around 350 megahertz. So this is why when you do PD measurement on the rotating machine, you need a sensor that can capture signal on certain frequency. Some some product they need to use the sensor with the maybe 20 megahertz or some maybe 100 megahertz, depend on the technology. But most of them they will use in the 100 level megahertz. Yeah, this is the ideally around 350 megahertz. But if you see the slot section, because in the rotating machine there are slot section and overhang, and this part can affect to the transmit the signal from the source of PD, because you know the slot section is shielded conductor, and with the depending on the length can have attenuation and also low impedance linear of the layer. So because this fact, so the signal from 350 megahertz maybe because attenuation getting reduced in certain maybe below this value. So this is why the range of the PD measurement on the rotating machine in range 10 or 100 megahertz range. And this is the some starter winding modeling. If you see the rotating machine, there is some slot section and overhang part. So with this calculation, we got this 2.6 megahertz value. So meaning, if you measure PD with the range frequency higher than 2.6 megahertz, the signal will trap. So I mean, it's not cannot capture the all winding. So this is why Megger, we use the frequency range below 20 megahertz because based on this starter winding modeling and also this reset, you can see we tried three measurements with different frequency range. With the first one is less than 1 megahertz, second one up to 20 megahertz, and the another one is up to 100 megahertz. So from here you can see clearly that the signal better when you measure below 1 megahertz, but this only can applicable when you use the offline method. When online, you just it's not possible because noise too high. You cannot capture below 1 megahertz. So the another option is we use the 2 up to 20 megahertz. At least you still get the signal same as with the less than 1 megahertz, but only different is magnitude. But the pattern is similar compared to the when you measure with the higher up to 100 megahertz, the pattern getting different. So at least you miss this pattern. So if you miss some pattern, it can misleading to analyze your PRPD pattern. So middle range frequency is good as frequency range to measure PD on the 30 machine. Just some comparison. So medium frequency range between 1 to 20 megahertz, reasonable cover signal, and best compromise for online monitoring. The problem with the higher, you have good on the noise near field detection, but limited cover. Problem of the higher frequency is the sensor cannot detect PD in all winding of the automation. It is the problem. So medium range is preferable to detect PD online on the automation. This is example how to install the coupler. Depend on your rotating machine. If small rotating machine, not many pole, maybe one coupler per phase is enough. But for turbo generator, because very large, sometimes one coupler is not enough to detect all signal from all winding inside the rotating machine. This is why we can put more than one coupler per phase, depending how large your machine. So normally we can check before we decide how many coupler. Yeah, we have this copper type, coupling capacitor type with 440 picofarad up to 145 picofarad for 20 kV, for 15 kV 220 picofarad, and 440 picofarad for 7 kV coupling capacitor. So this sensor can be installed permanently on rotating machine. Mostly we install on the terminal box. This is some example. So you can install this permanently and you do measurement either permanently, continuously, or you can do monitoring in certain time, maybe only 1 week or maybe 10 days, just to capture the partial discharge phenomena in your rotating machine. This is a general connection, not only our product, all product will be the same connection. If you have the rotating machine, you install coupler, one coupler for each phase. And from this one, we measure PD, connect to the small box, we call it CTB. And from this box to the coupler, we install permanently when motor start down. And from CTB to your instrument, you can measure install permanently or portable one. Yeah, we use this TV box, and some procedure can be used to pick up noise, depending the source of noise. If noise come from the grounding side, we can use the FCT to minimize the noise to your measurement. So sometimes we use the spectrum analysis to reduce some noise like affected by thyristor noise in some generator, or there is some noise, thyristor noise, meaning so you can identify from this signal. Mostly every 60 degree, you can see some noise. So if you select this, meaning there is some thyristor noise on your system. So with spectrum analysis, you can reduce this, you can avoid this noise, something like this. And this is the instrument can be used to detect to monitor the PD online. we have the ICM monitor with different type, 4 channel, 8 channel, and 12 channel. You can connect remotely or standalone. You can analyze directly, or you can remote from other place to see the measurement. Yeah, this is some example. We supply a special panel, a stainless steel cabinet with or without Peltier cooling, complete with the temperature sensor, CTB, preamplifier, all inside this panel, IP65. So this is good option to install to monitor your PD on your online rotating machine. Also, we have software to show the PRPD, and you can connect with the many communication, including with the IC 61H50. We can show the current reading, NKS, QP, and alarm status. And also can integrate it to your phone. If you see any alarm, can send a message to some of you to give information there is alarm of PD, so you can come and detect and analyze. And also, one software can be used to help you to analyze what type of the PD. We have the ICM Expert software. So after you got the measurement, you just upload and then try to analyze, and software will try to find from our database to find the similar PD that you got, and then finally you can see the final PRPD type recommendation by the software with some information percentage of similarity. Yeah, and the summary is, as you see here, the insulation failure are costly, and we try to avoid it. So PD monitoring system can be used to minimize that failure. But remember, this is only one of solution, meaning it's not possible with one instrument can detect all problem in your rotating machine, but at least you can cover if there is some insulation issue on rotating machine. And PD monitoring system can give more detailed information compared to the other testing, because from PRPD, it can recognize the source of the PD, whether the PD come from slot, from the void, from the overhang. So give you more detail compared to the other insulation testing instrument like Tan Delta or other, but still can be used. But I mean, PD online give you more detailed information. Choose proper instrument that can be detect PD on winding accurately, because as remember, different frequency range also can give effect to the measurement. High frequency range will lose some information from the all winding. So you can decide when you consider online monitoring. And also the last one is the PD monitoring system is one solution as assessment tool to detect any problem on the rotating machine related to the insulation issue without need to the energize your system. So you can detect early any failure indication. Yeah, I think that's all. I conclude this webinar. So Grace, I open here to you.
Thank you, Zumaedi. Thank you for your presentation. So now it comes to the Q&A session. If you have any questions, please type into the question box. Our panelists and Zumaedi will answer your questions. And for those of you who are leaving, please remember to have a fill in the survey, which is very important for our improvement. And you can see the survey on the right-hand side. And after filling in the survey, you can download an attendance certificate, which is at the bottom control panel. There's an icon on the right. And again, the recording of this webinar will be sent to you by email in 2 days' time.
I think we have question, Grace.
Yes, we have a question which is already answered in the chat box.
Okay. Can I read
Yes.
the question?
Oh yes, I can speak. Okay. The question is, and in related to the ambient temperature, what is the main effect or what happens if you energize the 6.9 kilovolt motor with low insulation resistance?
Okay. Thank you for this question. Yeah, actually, yeah, my concern here is you have low insulation resistance. So the next question is how low your insulation resistance. I mean, usually if your insulation resistance already fail based on your standard that you use, I think it's not. I think it is too high risk. Yeah, I mean, if you still continue your energize your rotating machine or your motor, so especially if there is the temperature getting high, because based on the rule, higher temperature can reduce the insulation half. Meaning if now you measure in the 20 degree, you have 10 mega ohm. So if you measure in the 20 degree, sorry, 30 degree, the insulation resistance can drop up to 5 mega ohm. So meaning half of your resistance, insulation resistance can drop up to 50% if there is a 10 degree Celsius difference. So meaning if you have low insulation resistance, I think it's not recommend. Better you don't try to uh, energize your motor because it's too risk. I think yeah, if you still continue your run uh, the your motor. Uh, yeah, I need to
All
know
right,
the
thank you.
how low yours is actually. Okay.
All right, thank you, Zumaedi. I guess we don't have any more questions. If you have any more questions, don't worry. You can send us email anytime to ea.marketing@megger.com. And just a reminder, we will be having another webinar next Thursday, 26th of October. Time is 10 a.m. in the morning, and the topic is power quality in wind turbines, focus on cable force location. So if you're available, please go to our website, www.megger.com/webinars to sign up for the webinar. And a reminder again, please remember to fill out the survey and download the survey kit before you close the webinar window. All right, just have another question coming in asking, um, can one use the equipment to measure PD in substation?
Can one use the equipment? Yeah. Our solution will be depend on the application. Okay. If you refer the substation, we need to know the what asset you want to measure. If the substation, because the substation there are many assets. Yeah, there is maybe CB or CT, VT. Yeah, for IS substation, we can detect. We can do testing offline procedure. We have the solution, but if you prefer online procedure on IS, I think we also have solution, but not really competitive. Yeah, because you need to install the coupling capacitor on each asset that you have in the substation. So if you ask solution, yes, we have solution, but we need to know more detail what asset you want to do uh, uh, testing or measure, and also you prefer online or offline. So from this information, we can continue discussion. Yeah.
All right, and the last question is, I think it's asking what's the standard resistance winding rotor and stator?
Yeah, the standard. Yeah, there is no clear information as I know. Yeah, there is no clear information about the value standard. the standard only mention about the differential unbalanced resistant winding between three phase measurement. If I'm not wrong, I need to check, but if I'm not wrong, it's around I think 2% or 3%. The delta resistance between phases, but to find the clear information about the value itself, there is no information. So maybe I can try to find again, but so far as I know, only the differential between phase if you test the winding. So you need to make sure the differential or delta winding between RST no more than 2%, or some of them using 3%. But at least 2% is good to as reference. If higher than 2% difference between ABC, meaning there is fail indication on the winding. Yeah.
Okay, thank you, Zumaedi. I guess we don't have any more questions. And again, if you have any more questions, you can send us email. So thank you again for attending. Thank you, Zumaedi, and our panelists, Michael, Bernardo. And we hope to see you again next webinar. Thank you, everyone. Thank you, and bye-bye.
Thank you, Grace. Thank you, everyone. And see you on next webinar.
Thanks, everyone. Bye-bye.